All right, cool. I think we're recording now. So, welcome everyone who's come in person and welcome everyone who's on the Zoom. This is the COP3503C midterm review that I've decided to run. So if you're here looking to study for programming too, you're in the right spot. With that being said, full disclaimer, guys, I'm not even a TA or anything. So like, if you put me on the spot, no guarantees I can like answer anything. Another thing is, obviously I didn't spend day and night making this presentation. So just once again, bear with me. So we're just going to get right into it. Basically, I set up this PowerPoint. If you go onto Canvas, there's like a review for the midterm. The way that I set up this PowerPoint is it basically just goes over the review, goes over like every single question and answers it. Alrighty, so first we got classes, which was the first topic on the review. It asks what encapsulation is. Encapsulation is basically you're taking a group of data, can be different data types, and you're finding a way to store it inside of like one object. So for example, let's say you had like a person, that's an object. Chris, don't objectify people. Well, that's besides the point, okay, I'll stop with the cringe CS jokes. But anyways, let's say you take a person, you might have like their name, their age, their height, right? You want to put all of that data into one object that's a person. That would be the process of encapsulation. Then you have constructors. The point of a constructor is to make a new object. So, you want to create something. And then we have, okay, so you have the invoking object. Now the invoking object, when you like try to access a function, is basically the object you're accessing the function with. So let's say we had a person, named Joe, and we wanted to figure out what his name is, right? And we did Joe.getName or something. Then Joe would be the invoking object. Now, in order to access Joe when we're running a function, you have to use the this keyword. Now, this is a type of pointer, which is why after this, you have a little like arrow little thing that basically signals that it is a pointer. It's not just a normal object. And then what's the function of the name that gets called when an object falls out of scope? That's a destructor. That's one of the big three. Later in this PowerPoint, we go over all of the big three. Yes. Yeah, so like the invoking object, when you like run a function, right? Let's say you had like I said, let's say you had like a person object, and then you had like a person named Joe, right? Or like you had a variable named Joe. And let's say you had like Joe.getName or like Joe.setName, like anything. The invoking object would be Joe. But like, and then into reference Joe, not reference, because that gets into references, but you know what I'm saying? Like, in order to like access like Joe's characteristics in a function in the class, you use like this. Yes. Not if it was a parameter, because like keep in mind like parameters specifically. So like if you passed him into a function, like using like maybe a copy assignment constructor or something, then like basically it would be like you would just use like Joe or like whatever the parameter name is dot and then his thing. But once again, this is like specifically if he's the one running the function. Yeah. Okay. So then we have classes part 2 because this was like a really long section. What's an accessor? So this is gonna basically get you the data, and it's going to return that data type, because think about it. If you're trying to access data, let's say you're trying to get a name, you're trying to get the data that is the name. So you get like a name, for example, would probably be a string. You're going to return a string data type. A mutator, on the other hand, it's not trying to get you any data. It's trying to change a piece of data. So once again, let's say you're trying to change a name. You're not going to return anything because you're not trying to access that data. You're not trying to read it. You're just trying to, change it to something else. So that's why you return a void data type. As far as the public and private keywords go, that's basically going to look at who can access this data if you're making a class. If something is public, it basically means you can access the data from anywhere. So that means you could even be outside of the class. Maybe you're even in your main file and all of a sudden you're directly accessing objects. Now, the issue with this is maybe there are points in time where you don't want to allow somebody to just access your objects outside of the main file or inside the main file and such. You want it to only be accessed within the class itself. That's when you would make something private. This is oftentimes done with variables. You're encouraged to make variables private and then use accessors and mutators in order to access them, not just make them public and try to do whatever you want with them. So let's see. So now I have just some examples of code that I wrote, and like basically this example with this person will just like, you'll see will be an ongoing topic like this entire presentation because I thought it was easy to make an example with. So here we have, you can see I've made this is just a main function, and in this main function, we have a few other files at the top. You can see we have a main function, we have a person.h, which is a header file, and we have a person.cpp, which is a C++ file, like type thing. So we have Joe is going to be made as a person, and we have 3 parameters that we're putting in: a name, an age, and a height in inches. And then we have another function, joe.printData, which we'll see in just a second. So now here's person.h. This is the header file. Remember, the header file is where you're trying to make a ton of prototypes. It's basically you're saying that these functions exist, but you're not actually like making like their functionality yet. You're just telling the program, hey, look, these functions exist, you can use them. But as far as the actual functionality of those functions goes, it's going to be in the person.cpp file. Now, if we look at this file, it's just, it looks kind of confusing because there's a lot of data, but really what it is we just have a print data function. If we look at the print data function, it's just like printing out like their name, age, and height. Then we have a constructor. This is not a default constructor because it does require that you put in some parameters, such as the name, the age, and the height. Now, notice when I'm referencing the name, age, and height in that constructor, you can see that this keyword is used to set like the name, because the reason you need to use that, so if you look at the person class or you look at the constructor, you can see there are variables that are named name and age years and height inches, which is the same variable that's the same variable name that as the class's local variables. So you have to use this to basically specify I'm using the variable from the invoking object. I'm not trying to use the variable from the parameter. Or parameter, not perimeter, parameter. And then those below, all those below, like I said, they're just getters and setters, or accessors and mutators, whatever you want to call them. And you can see that some of them use const, which we'll get into in just a second. But basically, they just return the data types, or they set the data types to whatever you want to set them to. So here's the output of that file. If you don't remember, when I went back to the main, hold up. If I go back to main, you can see we just make a new, we make a, yes. Oh, okay. So like the point of Pragma is like, let's say you have like multiple files trying to access like a header file. You don't want to like, I don't know the exact wording for this, but basically you don't want to compile the file like twice because it'll cause an error, or like 3 times, or that basically makes sure that the file is only like basically created once. So like I might have another file that's trying to access that same person.h file. Again, you don't want it like to create it twice. What Pragma does is make it so that it only ever gets created once. Like if it's already an open existing file, it's not going to create it a second time. See, it is, or like sometimes like C-line will like just like automatically do like the if define for you, which is the same thing, just more complicated. But also I've noticed that on like Zybooks specifically, using Pragma just sometimes straight up throws errors. So it's like, it's not technically necessary. And like whenever I'm submitting something on Zybooks, I actually don't use it because it actually throws like warnings and stuff. Yeah. It's really when you're using like multiple header files that, or like multiple things that are accessing that header. Yeah. Yeah. All right, so here we have const. How to create a constant variable. Use the const keyword. You basically put const just like in front of the type. How to pass a constant parameter. parameter, I keep saying parameter, you're going to take that constant, you're going to put it in front of the data type for the parameter, but you're going to basically make the function, when you build what the function is, you're going to make it just normal, just all of a sudden you have the const keyword in front of it. Now, if you want to take a function and you want to basically make it so that the invoking object is never touched, it's never changed, then you can also call, basically you can call that function as a constant function by adding the const keyword after the function name. So if I go back, hold up, you guys can see like get name, for example, that's a getter. You're just returning the name. You don't want to actually end up accidentally changing the object. You can see that const is added after get name. So that's just an example function. And then we have constant pointers, which are a little bit more complicated because there's kind of two ways you can make a constant pointer, and they both do different things, or you can do both. But so the first example we have where const is in front of the data type, you can see it's a integer pointer. Basically, what that is saying is that the data the pointer points to is constant, meaning that if you try to like dereference it and change the data, it's not going to allow you. However, technically, you could still change what the pointer is pointing to. You could make it point to a different object. So if we had like ampersand, like example 3, right? I could like reset this pointer A to like be the pointer to example 3. Now on the bottom, we have a different type of const for pointers. Now that's when the const, instead of like outside of the data type, it's just like inside in between the data type and the actual like variable name. Now this makes the pointer itself constant, but it doesn't make the data constant, which means basically you can change the data, but you're not, once that pointer is pointing to something, it's not going to be able to, point to something else. Now, if you're wondering why there's the ampersand right there, that is basically to reference that we are putting in memory addresses instead of just like the variable itself, because remember that pointers, what they're actually doing is they're pointing to a spot in memory. They're not, yeah, yes. I believe that is the case. I could be completely wrong, but yeah, I believe if you were to point it to a new pointer, then it's no longer associated with example 1, to my knowledge. Yeah, I mean, you could always test that out in like CLion just like to make sure, but I'm pretty sure like that's what would happen because now it's pointing to a completely different memory address. So yeah. So we have some memory allocation stuff. What does the new keyword do? Basically, so you got to understand like a little bit about the stack and the heap in order to understand these questions. Remember that the heap is like long-term storage, whereas the stack is like basically short-term storage that's in like just like a local memory. Heap is like a big space of memory where you're dynamically, by dynamically it means you control it, allocating memory to do certain things. So what the new keyword does is it's basically going to say, okay, I don't want to store this in just like my local small memory disk type thing. I want to store this in this larger memory that will basically be more permanent. So that way you don't get stack overflow or anything. Now the delete keyword does the exact opposite of that. It basically takes that data and it says, okay, I know that I have this data allocated at this spot. We're not going to allocate this spot for this data anymore. Now, that does not mean that it deletes the data. The data might still be there. It just means that it's no longer allocated, so something might change, and maybe later it'll be overwritten, but it's not going to immediately be overwritten. So keep that in mind. When you use brackets with new and delete, basically that's for making an array get called in the function. So like if you had like an array of data, right? And you had it, let's say you had an array of like 10 values, okay? And you had like the new keyword and you had all 10 values in an array and they all had to have separate new keywords, right? And then after that, you had an array. So you have that array that's being stored in memory, but then later you want to delete it, right? Like you don't want to have to go through individually like 10 of them, all 10, and like have to like call like a for loop or something. in order to like individually delete all of them. You can just use the brackets, and the brackets will get rid of the entire array's allocations. Now, a memory leak is basically when you have a piece of allocated space that is storing some form of data, but what happens is that data falls out of scope. It's no longer something that you can actually access. Maybe the variable is no longer being used, but you still have that allocated memory, which means that basically you have that memory taking up space and storing that variable, whatever the data was, for no reason. So when you have a memory leak, it means that if you have too many of them, you're just gonna have all this wasted memory that you can't allocate to other things because it's sitting there using memory for something that's old that's no longer being used. So that's why if you like do like the projects or labs or something, we have leaker, which is super annoying, by the way, just saying, but you have leaker like catching all your data leaks. It's basically so you don't accidentally use memory that you don't need. And then we have a deep copy and a shallow copy. Now, a shallow copy is pretty straightforward. It's literally just taking like a data, like let's say you had like, I don't know, you guys remember when you were doing the project with the nodes, right? You had a node with like a head and a tail, okay? If you were to make like a shallow copy, it would copy the head and the tail, right? But that's basically it. If you have a deep copy, the point of it is to take into account if you have dynamically allocated memory and basically accommodate that. So if you make a shallow copy of an object, let's say you have an object and it has 3 variables, and all 3 variables need a space allocated in memory. If you make a shallow copy of that object, you're going to get that object. But what's going to happen is the memory that is being allocated to the new object is still going to be that allocated memory, right? That same allocated memory, which is an issue because what if later, all of a sudden the previous object, like it falls out of scope and you delete it with the destructor, and all of a sudden that memory becomes deallocated. And now all of a sudden you have the second object that was using the same memory, and the memory is not even allocated anymore. So now you have an issue. So that's the point of a deep copy, is basically you're taking that object and you're giving it its own like memory to store it, so that if you delete the previous object, you're no longer deleting that object's memory space as well. Okay, so now I have just like some more code examples. This is just to show off like new and stuff. So we have an array, a pointer to an array, because whenever you make dynamically stored arrays, you always want to use a pointer. So we have a pointer to an array in somewhere in the heap that's storing 5 values. And then I just real quick had a for loop that sets the values, should be like 0, 1, 2, 3, 4, right? And then after that, we're just printing them out. And then after that, you can see we call the destructor. We're doing that by using delete. And basically, you can see there's the brackets there because we just want to delete the entire array. We don't want to have to go through each individual one and do it. We're just going to delete everything. So now if we look at the output of this code, you can see it's 0, 1, 2, 3, 4. You can see that in the print statements, I added the little commas. That way, it's just easy to see like between the different variables. So pretty simple code example. So then we have templates. Okay, so what's the point of a template and like what is it? So like let's say you have like a data type you're making, or rather a data structure in this case, where you want to be able to basically do the same thing but with different variable types. That's where a template comes in. Like for example, if you want to do like cout, right? If you take like a float or an int or a string and you do cout, like it's going to work either way, right? Like you don't need it to be a specific type. So what if you want a function like a print function, and all you want it to do is just print something, but like you don't want to have to write every single parameter for like every single data type, okay? You just want to, you know, say there's one print function, it'll take in whatever data type it is and print it out just like that. That's the point of using a template. You can basically take in any data type and just do common functionality automatically. So above there, we got what is the purpose of template type name type and a class declaration. Now, if you look at the type there, that's what you're going to have to use as your like new name for the variable. So if you call, like if you're saying, I just want to use whatever variable the person puts in, instead of like in all of your definitions and stuff, instead of saying use like int or float or whatever. You're just going to write in that example would be type, because you can see the second word right there is type. So this was a real simple, another really, really simple example with using templates that I just thought I'd show. So if you look up at the code, we have this println statement. If you've taken Python, you'll notice it really looks similar to Python. Now, basically what we have here, we have in the main, we have 3 different variables being created. And notice that all of the variables are different data types. But notice that we can basically take in any of those data types and use our new println function that we've created, which is just printing out whatever the data is in a new line. And if we look at the output for this code, that's the output right there. So it's just 5 cool and 5.95. So that's basically the simplest like example of templates I could think of. Next up, we have a stack and heap. We have to know these. So where does new memory get allocated? Now you'll remember we were talking about new and delete and all that stuff earlier. That gets put into the heap. Now in C++ specifically, this is not for all coding languages, but people refer to the heap as the free store. The heap is like a general term that's used for like just like any coding language basically. Free store is like something specific to C++. Now moving on. If you have a function and you want to just like store like the variables within that function somewhere, that's going to be all on the stack, which is short-term memory. And when you think about the stack, it is a data type or data structure, I guess. And we'll talk about that a little bit more later as to how the stacks work. Then you have Stack Overflow. So think about it like this. Let's say theoretically, right? I'm going to compare this to like computers, right? So like computers, you have like RAM and hard drive space, right? Like kind of simple, okay? RAM is like temporary storage, hard drive space, a lot of like, mass storage, right? Let's say theoretically, we were like just making all these variables. We made like this huge array and and we aren't using any new keywords or anything. I don't know, we make an array with like 100,000 values, and the stack, which has a small portion of memory, is basically going to get overloaded because it doesn't have enough memory to store that many data types. However, what you can do is to stop this is you can make a pointer and then you can point it to somewhere using new to put it on a dynamic allocation in the heap. But so basically Stack Overflow is when you try in one function to make way too many variables, you have way too much memory being taken up, et cetera. Now we have the big 3. So I mentioned these earlier. So there's this thing called the rule of 3, which is basically if you have like a class where you have one of the big 3 defined, you're supposed to define all of them because people think it will normally be necessary. So the 3 that you have in the big 3 are the copy constructor, the copy assignment operator, and the destructor. Now the copy constructor, something you got to keep in mind, it has the word constructor in its name. Now, if you remember, I mentioned constructors earlier, and the point of a constructor is to make a new variable. So that means that a copy constructor is you're making a brand new variable. The variable that you're making did not previously exist. So keep that in mind. The copy assignment operator is very, very similar. However, instead of making a brand new variable, you're basically taking a variable that already exists and setting it equal to the values of a variable that also already exists. Both of these, basically what you're doing is you're taking in another variable that already exists, and you're basically setting the data of each equal to each other. That's the point. Now, a lot of people are like, okay, why would you just want like a copy of like one piece of data? Well, like I think like the most useful like situation for this, let's say you have like a really big object with like a lot of data. I don't know, let's say you had a person and you have like their entire like DNA spectrum or something, right? And let's say you have another person and like they're like the exact, for some odd reason, they're the exact same DNA spectrum, but like they're just like named this, they're something different. I don't know. They're like identical twins, right? And they're just like their DNA is the same, but you know, they have different names. Okay. What you could do, right, is you could make a copy of one of the people that you already have, and then you could just like have all of the same data, and then all you have to do is just change the name. You don't have to like go in and like manually set like every single one of the same thing. Does that make sense, guys? Like It's really useful when you have objects that are going to be like large and you don't want to sit here like resetting all the data. If most of the things are the same, then you can just change like one or two things. Yes. Yeah, that is indeed how it works. Yes. Okay, so like think about it, right? How many times can you make a variable? Like if I were to do int x equals 5, right? And then I wrote like int x equals 3. Wouldn't that cause an error because I'm making x twice? Now I could do int x equals 5 and then I could do x equals 3. And that would not throw an error because it's basically making x, and then after it's making x, it's resetting x, right? That's the same logic with the copy constructor and copy assignment operator. The copy constructor is like saying int x. The copy assignment operator is just like saying x equals. I'm seeing if that makes sense. Like keep in mind, like if you were to like do like 2 int x's in a row or 2 any variable, like you can't make a variable twice. Like for example, if I was making a person, right? Once again, going back to that person object thing, right? Let's say I was making a person named Joe, right? And I made him and I said person Joe and I gave him parameters. And then I made another person and I named him Bob, right? And like if I wanted to use the copy constructor, right? I could say, I would be using it like I would be creating Bob by using like the person in front of him. I'd be creating Bob and then I would say Bob is equal to Joe. But let's say I created Bob and then I wanted to set him to another guy, I don't know, like Jimmy, right? Okay. I couldn't like create Bob again. I couldn't say person Bob equals Jimmy because I've already made him. I've already said person Bob equals Joe. So what that means is that essentially I'd have to just set Bob to be Jimmy. I couldn't like remake him again. And that's when I would use the copy assignment operator. Like the only difference between the two is one of them is you're creating a new object and one of them you're like setting one equal. Why do we have a copy constructor? I mean, like realistically, there's probably no reason. Like you could always just make a new one, but let's say maybe you don't have a default parameter. Like you have a parameter that like only takes in, like if you put specific values in, the point of that would be so you don't have to basically make a new object with like random data just to assign it to something. You could just do it all in one go. Yes. Yes. Because when you make them, like it's making completely separate objects. So then they're just like normal after they're made. So yes, you can use them to like make new ones. Was there a question back there? I saw like. Yeah, they're two separate objects once they're made. So yes, you're good. We also have the destructor, which we basically talked about earlier, which is just deleting everything that you've allocated in dynamic memory. Once again, keep in mind that the default destructor does exist, but also it's not always what you want. For example, like if you have like a linked list, you can't just delete the head and the tail. That's what the default destructor would do. It would just delete the head and the tail. It wouldn't delete all the things that they're pointing to. So that's why you have to sometimes make your own destructor. All right, so back to examples. We have Joe being made, and then we have Gerard, and then we have Ricky, okay? Now you'll notice, right? Like when I made Ricky, I literally set him to like be like random values. And that would be the point of having a constructor. Like technically I don't have to do that. You see how like with Gerard, right? All I have to do is say person Gerard equals Joe. It's easy. But if I want to use the assignment operator, I literally have to make Ricky with like some random values, and then I have to set him equal to Joe. So that's why you would actually use the constructor as opposed to the operator. With that being said, if we look at this example, we can see what's happening, right? Joe is made. We have Joe. He's 18 years old. He's 72 inches tall. And then after that, we have Gerard, and we're just making Gerard as Joe, but then we're just changing his name to Gerard. Maybe he's the same height and the same age. And then we have Ricky, who's once again the same height and same age, but now his name is Ricky. But this time, I wanted to show off the assignment operator. the copy assignment operator, which means that first we have to make Ricky, and then we have to set Ricky equal to Joe. So really the difference between them is you see how like we have the data type and then Gerard, that's a copy constructor. Whereas with Ricky, we don't have the data type. We've already made Ricky in the past. Yeah. Yes. Yeah, that would make sense, yes. So then here we, yeah. So. These would be making, so like, the thing is like, I'm not really allocating any memory. So like, you don't really need like the difference between the two right now because it's not using like new or delete or anything. So like, technically these are shallow copies, but like they're still perfectly fine because none of the data that we're making is like actually on the heap right now. It's all just like on the stack. So then we have, these are like how the, you can see the top one is the copy assignment operator. That's how you would actually recode it. And the bottom one is the copy constructor. Now you can keep in mind that like a constructor is like just like the class name and then like the input, whereas the operator, you have to use like the operator keyword and like equals, and you can actually do that with like any operator. Like you can do like operator not equals and stuff, and you can still redefine them. And also you can see like the thing that you're supposed to pass in is usually a constant, because you don't want to actually change the person you're copying. You just want to like make a new object, right? And you're also passing in like a reference to that, that object as well. So you can make sure that you know, I'm assuming I could highly see this being on the exam, like knowing like just like the structure of how to set these up. If you return this, I believe you could use that with a, I'm trying to think. I know that, yeah, I know that that's definitely a thing, right? Like you return asterisk and then this. Maybe the assignment operator. Yeah, you're right. So for person operator, right? Yeah, you're right. Okay, basically what it's supposed to be here, this is my bad. I just like typoed while making the presentation. But anyways, what you're supposed to have here is like, you see how the operator equals is void? That's supposed to be your person and then you return this. That's what it is. Yeah. But anyways, this is what the output would be for that. I'll make sure to edit that like when I actually post the slides. Yeah, it's asterisk because you want to put, like you want to dereference it. We will get that in, we'll get into that when we get into pointers, don't worry. You want to dereference it though. All right, so then we have debugging methods. And like I said, when I post the PowerPoint for like everyone, like I'll just like edit that, like put a new picture. But anyways, we have debugging methods here. Honestly, I skipped lectures on this, but we'll figure it out. So basically you have print debugging, which is like when you have like a function running, right? You might notice that it stops somewhere, or like your code's not running properly, but like you don't really know where it's not running properly. So what you do is you just add like cout statements, and you're going to try to see like where the cout statement is like not running anymore, essentially. That's like very useful. Like what I would do like when doing projects, right, is I would just put a million cout statements, and like one would be like testing one would be testing two, one would be testing three. And then like, I just like look at, okay, where is it all of a sudden not printing anymore? And then I would know, okay, now I know the issues around here type thing. This is where it's stopping running. So maybe you have an infinite loop or something along those lines. A breakpoint is basically in your IDE. It's a feature that allows you to stop code at a specific time. So yeah, if what?
No, it's the one with like right before. Like, yeah, so like the one after that, and after you step into it, it's gonna run that. Yeah.
Did you hear what he said? He said, so like it stops at the one before it, but then it gets to that line and it's going to step inside of that so you can see what's about to happen. Yeah, there's a button to step in. And then after that, you can step into it. Yeah. Yeah. So anyways, we have basically, after that, we have two main functions while debugging. Once again, these are IDE based, and to be honest, I've never used either of these functions, but they're still existent and we still need to know what they are. Basically, stepping into a function is like you're jumping into the function, you're getting like a better look. So like if we go back to like my examples earlier with like print data, right? Then basically what we do there is you would take that, like if you were to step into it, it would start showing you like what the print data function like actually does. And if you step out to it, it goes back out to like the main code. And then what is a call stack? Well, it says it in the name, it's a stack. The call stack is basically like a stack of functions. And I don't think, like when we were talking about stacks, I forgot to make this analogy, right? Like a stack is like a stack of books, right? If you're stacking books on top of each other, then like when you take one off, you're taking off the last one first, which actually now that I think about it, we get into this later. But anyways, point here is call stack is a stack of functions that your program needs to run. It's basically as it's running, like your program might run a main function, right? And then inside the main function, it might run a print data function. So all of a sudden the print data function gets stacked on top of the main. And then maybe in the print data function, it runs a function where it needs to access another function. So that function will get stacked and it's going to keep stacking things. And then when it goes back, like first it's going to have to get rid of whatever the function that print data called. And then it's going to have to get rid of print data. And then finally, it'll get rid of the main function that's running. So it's like basically you're stacking things on and it's what it's going to actually like the function is happening. Yes, okay. Then we have file IO, which by the way, I didn't add binary IO to this PowerPoint because it wasn't on the study guide, but I'm not 100% sure if it's going to be on the exam. Some people have told me it is, but some people have told me it's not. I don't know. Is it not? Okay. Okay, I'm really glad if it's not because to be honest, aside from doing the lab, I haven't studied binary IO at all. So yeah, that's just kind of how that works. But anyway, so file IO, just wondering like when you guys were told it wasn't, was that like from like Resh or from TA? Okay, cool. That was from, okay, there you guys go. So binary IO, not on the exam. So anyways, we have three file IO classes that we use, offstream, ifstream, and fstream. Now basically offstream is you're going to write data to a file, whereas ifstream is you're going to try to read data from a file. So what that means is that like if you have like a text file, right, and you use offstream, then you can, you know, obviously put data into that text file. Whereas if you're using ifstream and you have a file that like already has data, it means you can take that data in and use it for something else. Now, another thing that it mentions, oh, and for fstream, that can be either or, and usually when you do like the hashtag include statement at the top, you just use fstream, so it's either or. Now, then for delimiters, they're basically just like anything that will separate data in a file. An extremely common delimiter is commas, and that's why we have CSV files like comma separated values or something along those lines. But basically, it's using commas to figure out when like one piece of data starts and when one piece of data ends. So yeah, just make sure that you know that. I don't know, obviously I have no clue what's going to be on the exam, but we could get a question like what do CSV files use? Oh, okay, yeah. So I know what you're saying. So like you're asking like, so like for ifstream, right? You're like it's gonna be the same concept as like a cin. So it's gonna use like, so like, okay, hold up, Brad. Let me get a marker. So like for ifstream, if you have like an ifstream object, let's say you just have like one named input, okay? And when you're using ifstream, you're gonna use this one. But then if you have like an offstream, right? Let's say you have an offstream named output. Okay, you're going to use this one. If like this is basically kind of like cout, and this is kind of like cin. Sorry, this marker is like about to die, so it's like really hard to read, but like, yeah. Okay, so think about this, right? For ifstream, you're reading a file, which means you're inputting data into a variable from that file. It's like, that's the logic here is the reason they say it's reading is because you're taking data from a file and then you're inputting it in a variable in your code. Yeah, whereas, Yeah, I don't know. Like these are the signs you use. I would highly recommend memorizing these. One of these, I think this is insertion and this is extraction, but can somebody confirm that? Yeah. Yeah. So like this is an insertion operator because my logic for that is basically we're inserting whatever data we have here. We're inserting into the file, right? Yeah. I'm hoping that we won't get a question that's like, all right, real quick, tell me the difference between insertion and extraction operator. Like that's like so tiny, but yeah, I don't know. I use this a lot during like lab 4 and lab 5, but I don't know. Anyways, yeah, I think I did. Actually, maybe you could have just used, maybe you actually could use just get line, in which case you wouldn't use them. Yeah, and then for lab 5, since it's binary, you just use like read and write or whatever. So yeah, I guess you don't technically have to use this if you're using get line. That's probably why you're confused. But still memorize them. I don't know what else to say other than like figure it out. Like just it's memorization. Anyways. All right, so now we have like some slightly more complicated stuff here. We're going back to our people example. We're creating people. However, with this, what we're doing, if we look at main, right? So first we have an off stream called output, right? And we're using this this file that I made called people.csv. So it's going to be a comma. So wait, I don't even know what just happened. I just zoned out. But anyways, so yeah, we have this output file called people.csv, right? Now, initially when running this code, people.csv was empty. It was just like a random file that was just named people.csv. It had no data in it. What this output file did was it takes this data and it's gonna, basically, you can see there's 2 strings and then there's new lines. And it's going to take this data and, put it into the file. So now, after I initially run this code, when these first 3 lines run, what's going to happen is when I check the people.csv file, we're going to see those strings in the file. Then I have an if stream, an input stream, right? And once again, it's accessing people.csv. Also, if you see at the top, I should mention, you can see include f stream. And you can also see include person.h because this is once again using the person class that I made earlier. So now if we have the if stream with the input, we have people.csv and we have Joe and Gerard there. And notice how when I made Joe and Gerard, like I made them with random values. They're like, I'm just like declaring them a thing basically. But anyways, now we go down, we have a string called a buffer, and I'll get into that in a second. We have a string for the current name. We have a string, and then we have 2 unsigned ints for current age and current height, just because when I made the current age and current height variables in the class, I just made them unsigned because, they can't, like you're not gonna have somebody who's negative years old. So I was just like, okay, might as well make it unsigned. Same for height. You're not gonna have somebody who's negative inches tall. So anyways, so we get into this for loop right here. There's only 2 people, so that's why I just said I is equal to 0 and I is less than 2. For this example, of course, you could set that equal to like, you could put this into a function where like maybe you say how many people do you want to add, and then you add like a ton of people or something, or use a ton of data or something. Yeah, yes. You can go. Wait, say again, I just couldn't hear. Yeah, F stream is just to like use these functions in general. Like it allows me to use off stream, the off stream and the if stream like data types basically. So they're yeah. Yes. F stream. Oh, S stream. I never even use S stream. I just use F stream. So I don't know. It just always works. I just use like, I think Fstream, I've never run into something where like it hasn't worked. I just use it for everything. So. Yeah. So you're like saying like you pass in like a Boolean or something? Yeah. So basically, also, what time is it? I'm just curious. 7:20? Okay. I was like, because like I said, I want to try to like get through all this by 8, but I think we're actually good on time if it's only 7:20. We're on slide 22 out of 31 right now. So anyway, so if we look at this, like if we continue down this, we have the buffer, we have the current name, which is like, okay, current name, current age, and current height. They're basically all temporary variables that they're just going to be overwritten later, but we're going to use them for something. So notice basically what I have here is we have some get lines. Now the first part of that get line is basically saying what is the if stream we're going to use. And the second is that buffer. Now buffer has to be like a string, and basically it's going to take whatever data it's reading and it's going to put it into that buffer as like a string, okay? And then we have the third parameter, which is the delimiter. It's basically saying what is the file that we're reading from using as a delimiter so we can figure out like which data is like which data, okay? So then what we're going to do, notice in the file, right, when we input the data, we put it in a specific way. We put it in, if we look at the outputs, it's always the name and then the age and then the height, right? So whenever you make some form of file, and like Excel will do this automatically, you always want to make sure your data is just it's like actually structured. You don't want to just like randomly input data that like you don't really know like what is what. You want to put it into a structured format so that then when you go to code something like this, like it's somewhat easy and it makes sense, okay? So anyways, so we're going to get the line and we're basically going to get the entire line until we get to a comma. And then the first one is going to be whatever the name needs to be. The second one is going to be whatever the age is. And the third one is going to be whatever the height is. Then I said if I equals 0, we're just going to set Joe, and else there's only one other option, it's going to be 1. We're going to set Gerard to that person with those temporary variables. But then once those people get created, they're going to be like actual people, and those temporary variables are no longer like necessary. They can just be overwritten and it doesn't matter. And then we're just going to print their data, which once again uses the same print data function as earlier. So if I go and I look at the output of this code, we just have name, Joe, 18 years old, 72 inches. You can see that name and Gerard are on separate lines. I need to edit. That means I needed to edit something basically to make it so it's not doing an extra endl. But basically you have Gerard. You have a Gerard object and you have a Joe object. And those two things are being printed out. So we have pointers. This is where we get into pointers. So fun. First of all, we need to know how to assign a pointer to a variable. We have int a equals 5, right? And a is an integer, just a number 5. But then we have int, and we see that asterisk, I don't know. And we equals, and you see how it says equals and a, the ampersand. The ampersand is there indicating, not that it's a reference, but that it's a memory address. Because remember, when you have a pointer, it's pointing to a memory address. It's not like pointing to the actual object itself. So keep that in mind. Now to dereference a pointer, which is basically instead of get that memory address, you want to dereference it if you want to get like whatever data is actually stored in that memory address, you're going to use an asterisk before when you're trying to access that. So you can see in the example I have right there, we have cout and we have an asterisk and then cool pointer, and that would then print out 5 because the data that it's pointing to is 5. Then we have the indirect membership operator. So, and that's used, I don't even know, I think I like messed up. I didn't put in the question, but basically remember that the indirect, so like you can see, how do you dereference? Okay, there we go. No, I don't mind. The question's right there. Dereference pointers to the class objects. So like when you're accessing an object, like let's say you have like a class and then you're trying to access like a name. Let's say you have the person and you have a pointer to a person, and then you're trying to access like the person's name. You wouldn't just like do like person dot, or the pointer, whatever the pointer variable is, dot name, because Now you're like trying to like access it through a pointer, and that just wouldn't work. You're not dereferencing it, so that would just print out like some random memory address type thing. In order to dereference pointers in a class, right, that's when you use the little arrow, which remember, if I mentioned when I mentioned earlier, there's this keyword, which is a pointer, and that's why whenever you're using this, you always use a little arrow after it. Once again, so like, let's say I had a pointer to a person. Let's say I had a pointer called pointer, and pointer was pointing to Bob, okay? And instead of accessing Bob, for whatever reason, instead of saying Bob.getName, I wanted to like use the pointer to access it. I'd have to use like pointer, and then a little arrow, and then getName. And to get the address, you just put the ampersand in front of the object, yes. Oh, yes. This one? You could directly put that in. Yeah, I was just using the buffer just so I would have like the same format. Okay. Okay, so basically, guys, here's the deal. Resh says binary philo is on the exam, but TAs say it isn't, and apparently they've seen the exam. So I don't really know. I'm going to assume it's on the exam, but like I hope it's not, okay? Yeah, I would say, do you guys hear what Kyle said? He's like speaking words of wisdom here. Probably look over it. Look over it, but spend more time on other things if you're gonna like study, which hopefully you're studying because the exam's tomorrow. But let's see, pointer part 2. Yeah, I have to do that. Pointers was another long one, so I had to split it into 2 slides. So yes. Oh, that was just how do you get the address? It's just basically put the ampersand in front of a variable. So it's like, you can see like the A, right? You can see how it's like when I assign the pointer to A, like I put in the and symbol in front of the A, basically. So that tells you the pointer is pointing to the memory address. And we have references. Oh, wait, no, I have to do pointers per 2. My bad. All right, so then we have passing pointers into a function. You can just like, you can see that example right there is actually like directly from one of Fox's slides. Basically, you can just make a function and you can basically make the data type like a pointer. You can see that the hero has the asterisk next to it to say that, you know, you're passing in a pointer, you're not passing in just a normal variable, which means that when you pass something in to that function, right? If you just, let's say I had a hero object, what's like a cool hero name? I don't know, anybody? Batman, okay. So let's say we had Batman as a hero, right? If we were putting this into a function, yes, Bagman. Oh, Bagman. Okay, let's say we have a function. Okay, we have a hero named Bagman, right? We're passing Bagman into a function with a pointer, but the function's calling for a pointer. Would we just put in Bagman, or like would we put in something else? So we have a function, right? The function calls for a pointer to a hero. If we were putting, right, you would put in the ampersand and then Bagman, because that way it's putting in Bagman's memory address. That's like what a pointer is. So yes, basically you would, the little and symbol. Yeah, the and. That's called an ampersand. Asterisk is a star, ampersand's the and. Yeah. Bagman, you really had to do that to yourself, bro. I mean, can't say I disagree, but you know, that's besides the point. But anyways, so what's a null pointer? That's basically, it's just going to point to, you know, nothing. If you look at Fox's lectures, he defines it as having undefined behavior. It doesn't really know what it's pointing to. It's just pointing to nothing. If you try using it, you might get an error. You might not get an error. You might get some really weird stuff. There's not something I can say that will be specific. It's just going to be random. What's a dangling pointer? All right, so you set a pointer, right? You set a pointer equal to some memory address, right? Okay, cool stuff. You set it equal like something in like, I don't know, stack or the heap or whatever. Or yeah, I guess in this case, the heap. You set a pointer equal to something that's stored in the heap. And then later, the destructor gets stored on that thing, right? Or rather, not the destructor, rather you unallocate the data to something else. So basically what that means is you have memory that was in an allocated spot, but then that memory was deallocated, or rather that variable falls out of scope, and that memory was never deallocated, or that pointer was never reset. And so now it's just pointing to something in memory that like is just kind of like non-existent type thing. Like it's pointing to a space in memory that's not allocated anymore to that thing. So if that space in memory gets changed, it's no longer going to give you that value. Like it can get overwritten and stuff. So basically the dangling pointer is a major issue. You can't have a pointer pointing to an object that once was saved in memory and is no longer like purposely allocated. By the way, whenever I say the word allocated, right, like that's just like a general term for like, you're basically saving, you're saying that this space is like reserved. So like, for example, we're in this room, right? Technically, I never allocated this space because I didn't go through an official process to like get this thing, you know, like saying this is our space for right now. We're technically like in here like slightly illegally, but that's besides the point. You know, but like if somebody were to walk in, right, and like all of a sudden, like let's say we had like all of a sudden a ton of people walk in, like if we had an exam, we would technically have to get out for them because they would have the space allocated. But if you allocate something, it means you reserve that space for something specific. So you actually go through a process to say, don't use this space for somebody else, okay? Then we have references, and I'm going to be honest with you guys, I'm not a super duper genius on references because I barely ever use them. But on the contrary, you're actually supposed to use references more often than use pointers. Basically, you're only supposed to use pointers if, well, we'll get to it in a second. Like there are a few reasons you don't want to use a pointer, but or there are a few reasons you would want to use a pointer instead of a reference. Anyways, how do you make a reference? You're going to basically, like, you know how we use the asterisks for the pointers? You're going to do that same thing, right? But instead of the asterisk, we're going to have the ampersand all of a sudden. So now this is something people get confused about because here's the issue, right? We have this ampersand, and this thing can mean two things now, which is really annoying because it can mean that we're making it a memory address, or it can mean that we're making it a reference. So just keep in mind when you have an ampersand like after a data type, it's being used to be as a reference. Whereas if you have an ampersand before like a variable, it means that it's being used as like to say like what memory address it is. Yes. Yeah. Right. And what Kyle is saying is you can see it's only on the left side. You can see also like when I say person, ampersand, some reference equals person, I don't like put an ampersand or an asterisk or anything in front of person. It's just person. Because when you make a reference, it's basically saying these two objects are the same object. Yes. Yeah, so like the reference, you can see like the ampersand, you see how it's like right next to person, it's like right next to the data type on the left. Whereas if we were using the ampersand to like do a memory address, it would be like to do a memory address, you see how like person's on the right, and the ampersand would be like right next to person basically, or like in front of person. Yeah. Yes, V. Yeah, so like what she's saying right now is like, and this also goes for pointers too. You can put the ampersand either right next to person, or you can put it right next to some reference. And that also goes with pointers. You can put the asterisk right next to the data type, or like to the left of the actual variable. There's technically no right or wrong answer. I always prefer to put it next to the data type because then you don't get confused with making it a memory address. If you just stick to putting it next to the data type. Don't be that one person, like I remember like when Fox was talking about this, don't be that one person when you're making like a pointer or like a reference type who like puts it in the middle of it too. Like that's just cringe. Yeah. This might have been on one of Fox's like recorded lectures. Yeah. Oh, oh, yeah. Oh, okay. I see what you're saying now. But yeah, just don't put it in the middle because then it looks like a math operation and then people will hate you. They'll be like, this code is not very good. And we have building, I think this is almost the end, by the way. Building C++ part 1, preprocessor directive. This is going to be like making some translation units. This is like such a fancy term, but it's basically all those things you see at the very beginning, like the hashtag define, if defined, hashtag pragma, if you just use that instead, and then like all your include statements. That's going to be in the preprocessor directive. So then we have the 3 stages, which you need to know. I'm assuming it's not going to go super duper in depth on these. You probably just need to know like what order they go in. But anyways, with preprocessing, that's going to create these translation units. Once again, that's fancy terms for just like all the stuff at the top. Then we have compiling, which is creating the object files from the translation units. So it's like basically making sure your function is actually able to be run successfully type thing. If you have a compilation error, if it can't run correctly, then you're not going to actually fully compile. And then we have linking these object files to an executable, so then actually performing the function. So that's why like when you're running code, you'll notice first it'll like build, and then after it builds, then it will like run. It's not just like a one step, like we do everything real quick. Like first it's going to basically check to see if it can actually run properly without issues, and then it'll actually perform the function it's supposed to do. Part 2. Okay, what is the purpose of a prototype? So basically, I talked about this earlier, like when you have like the header files, right? Like a prototype. So the issue is like C++, when you're reading code, right? It reads it from top to bottom. So basically what that means, let's say you have like a couple functions, right? And let's say you have 3 functions, right? Function 1 is on the top, you wrote it first. Function 2 is in the middle. And then function 3 is like at the bottom, right? Now, if you were to call function 1 in function 3, there would be no issue because function 3, by the time it's running, has already seen that function 1 has run. However, let's say you tried taking function 1 and then essentially you try to call function 3. Well, the code is running from top to bottom and function 1 at the moment doesn't even know that function 3 exists. So this is going to throw an error. The point of prototypes is basically, so you have declarations and definitions. Now, a declaration is saying that something exists, basically creating the object itself. And then you have definitions, which is actually saying what the function will do. So the prototypes are basically only the declarations, and it's just they're saying they exist, they are going to exist, whereas the definitions you can do separately and say what they're actually going to do. What this means is that basically you can write all the prototypes out first, and then after you write out all the prototypes, you can actually define all the functions and say what they're going to do. Because they're all at least existent beforehand, when C++ runs, they're going to at least see that they exist no matter what. And then you're not going to have any errors with the issues with those errors of a function not knowing another function exists. Then we can, okay, how to break code up across multiple files. Now this goes all the way back to like different classes and stuff and object-oriented programming and all that. If I scroll all the way back to like the original person example, you'd see that. But basically, you're going to usually, typically, you don't have to do this, but you're going to usually have a header file and then a C++ file. The header file is where you'll put all the prototypes, and then the C++ file is where you'll put all the definitions. Now, as far as this goes, basically you're going to put include and then the header file name at the top of your program. You don't have to put include and then like the C++ file name. But now when you go to the C++ file, you're also going to include the header file. So it's kind of like the header file is like a link between the two. Finally, we have the purpose of the scope resolution operator. So that's this like little double colon type thing. And this is going to tell you basically where you're actually pulling a variable from. You can actually use this as a this low key, and it'll still work. In fact, if you go into CLine, if I went all the way back, hold up, let's go all the way back, guys. Let's see if I can find it real quick. Notice, so when I made these getters and setters, like I used this for like the person. That's a function like I just completely wrote on my own. Whereas for all the getters and setters, I actually just made CLine automatically do them. You can literally right click and click generate getters and setters. Notice when CLine, yeah, did you not know you can do that? This is tragic. But anyways, notice when I had CLine make them, when I had CLine make them, instead of using this, instead of using this, it just like used the person and the scope operator. So that's just like another use, but it's basically saying like, where are we getting the data from this variable? It's used to say like, does this variable actually exist or function or whatever? What file are we getting this from? What class, whatever. Okay, yes. For which one? So like you're saying like right here, you could use this or like, which one? Right here? I don't think you could do that. I don't think you can use this here. You could use this here on the second one. You can't use it here because I could be wrong on that, but I don't think you can use it there. You just like, okay, so it might differ in Visual Studio Code, but for C-Line, right? For C-Line, basically what you do is like, first you have to define them, or not define, I take that back, not define, that's the wrong wording. Declare them. You have to declare them, yeah, in the header. You just go into the header file, you right click, there's a button that says generate, you click generate, and then it'll come up with like a list of all the variables that you have created basically. And then you just select whichever variables you want to make a getter and setter for, and you click OK, and then it makes them all automatically both in the header file and in the C++ file. Like it's all automatic. Yeah, it puts everything in there. Like these pieces of code, I literally didn't even write. I literally just right clicked and like it just did it for me. Like I didn't do a singular thing for them. I declared them in the header file, yes. I declared their variables existent. That's all I did. No, it adds it also adds the functions to the header file. It has to declare the functions in the header file. So like no. When I say like there are variables already made, right? Like, I mean, like you have to have like the age years variable already made. You don't have to have the function already made. You don't have to have the function at all. Yeah, you just have to have the variable itself. Yeah, it does basically everything for you. Let's see, back to where we are. I think we have like maybe one more part. No, two more parts maybe. Yeah, 2 or 3. Yeah, two more parts. Data structures. Okay, so obviously we have an entire class on this we have to take at some point. So I'm sure we'll go very, very much further in depth. Not quite yet. So we have a stack. This is where I was supposed to talk about the stack of books, right? All right, let's use this stack of masks. It'll work. So I take this one mask, I put it on the bottom, that's a function. I take this other bag of masks, I put it on top, right? That's another function. So unless I'm like some like super Jenga master or something, right? Like if I wanted to basically take this bottom set of masks, I would probably have to take this one off, right? That's how a stack works, okay? Look, I put one in first, and then I put another one in. Now the first one out is gonna be like the one that I put in most recently, basically. So that's known as a first in, last out, actually, because the one that I put in first is the one I'm taking out last, okay? Now for a stack, yes. It's the same thing. Yeah, you can use either or. So like they mean the same thing if you think about it. Like first in, last out is the same thing as last in, first out. They're interchangeable. So then we have so for a stack, right? The keywords you need to know is push and pop. Push is basically adding a piece of data onto the end. Pop is popping the last one off. Now for queue, right? A lot of people they don't really understand queues at first because they don't immediately think of something to compare it to. But there's actually something super duper easy you can compare a queue to. Like you guys all have like Spotify or YouTube Music or something along those lines, right? What do you think like music playlists are? They're a queue. You put a piece of music in. I would say Discord bots that play music, but also YouTube axed all of those. So anyways, but if you have a queue of music, right? Like you put a song into the queue and then it plays that song. And then after that song plays, it ends and it goes to the next song. Well, that's exactly what a queue is. You're going to add data types in, variables in. And the first one that you put in is going to be the first one to go out. So it's first in, first out, or like last in, last out, whatever you want to say. That's for Q. And for this, you're going to use DQ and Q as the words, or on Q maybe. It differs sometimes, but on Q, DQ, Q, whatever, same thing. For linked list, I mean, I'm sure you guys all somewhat know what a linked list is by now, considering we had an entire project on it. I'd hope so. But basically, you're going to have some nodes. Now, a node is going to be like a nested class inside of your linked list class. What this is going to be is you're going to have your piece of data, which hopefully can be any piece of data that uses a template. And then after that, you're going to have 2 pointers. Well, actually, technically for a linked list, you only need 1 pointer, and then it would be a singly linked list. But like, we're not losers, okay? We're making a doubly linked list. So we're going to use a head and a tail, right? Basically, the head will, or we're going to have a head, which will be the front of the list, the tail, which will be the end of the list. Now, the node will have a pointer. It'll have a next pointer and a pointer to the previous object. The head, because it's the first part of the list, the previous will be null pointer. The tail, because it's the last part of the list, will have a pointer that is just like null pointer, a next pointer that's null. So that makes sense, right? And when you go through the list, instead of like having like an array or something, or a vector or whatever, when you go through a linked list, it's basically just like all using pointers. So you have to like go like next, 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 next in order to get something new. Then we have what's the difference between an array and a dynamic array, aka a vector. Basically, a normal array, you're going to have fixed length, whereas a vector is actually an object that we can import, luckily. A vector is, you can just add things in and take stuff out. It doesn't have to have a set number. You don't have to determine it beforehand. And that also means that you can create a vector like without any values at first. It can have nothing in it, and then you can just like add it in. Whereas if you create an array with nothing in it, it's literally completely useless. Like, don't do that. Yeah. Finally, we have command line compiling. Once again, not something I'm an absolute genius on, but we'll figure it out. Basically, you're using command prompt to run code. There's also like a million of these. Like, you can use like git bash or like PowerShell, or like, I don't know what Mac uses, but Macs are gross anyways. So I'm not. So there are 2 commands that Fox wants us to know. The first one's cd, which is change directories. Now, what's that? Now, when I first like looked at these, like way long ago, when I was first looking into like bash and all that, right? I was like, dude, what the hell is a directory? This makes no sense. Okay, that's a fancy name that they decide to use for folder or location. It's like, what folder are you in? So we have dir or like ls. Okay, so ls and dir are the same thing. One of them is Windows, I think dir, and one of them is ls. That's like Mac. Yeah. You have a Mac, right? That's why you use ls. Mac, okay, so they're the same thing. You have to just know they're the same thing. Well, so when it says shows the contents of the current directory, it means it's showing the contents of the current folder you have selected. We have a makefile. I remember I had to use one of these guys way back in the day of like an entire year ago when I was like trying to get a Minecraft server running off of a Raspberry Pi. That was some good stuff. But anyways, basically a makefile is like you have like this file and it just has like a ton of instructions that it has to run. And when you call that file, it's going to run whatever instructions it has inside of it. And then you use the make command in order to read the make file and like actually execute it. Probably not, but I'll tell you right now, like usually if it's like, I don't know, if we get a question like, what is this? And the answer is a makefile. Like usually makefiles, for some reason they use underscores like in between the functions. It's just how it works. So basically I don't really, hold up. If I like, you want me to just like pull up a picture of one? Because I don't have one in the presentation. Like I don't think you're gonna have to know what these look like, but I'll pull up a picture of one. Hold up. Let's see. I know that you guys on the Zoom will only see the PowerPoint, but oh, that's my email. Don't worry about that. Let's see. So basically that's what a make file looks like. Once again, I'm sure, I know you guys in the Zoom can't see this, but I'll like, put this in, I'll put this in the Discord or something. Yeah, so like you can see like this is like what it's basically asking to do. I'm no genius on these things, but it's basically if you have like an output here, right? You want it to like, run this. G++ is saying it's going to run this. It's going to use main.o, and then output will be the file it is, and message.o. I have no clue what that's doing, but it's an example of one. Once again, I don't think, I don't know if you can see what it does at the very top. It's like right there. Anyways, back to this PowerPoint. Oh, screen sharing stopped. 1 second, guys. I'll get that up in just a second when I get the PowerPoint back up. Let's see. Yeah, hold up. Let me unmute you real quick. Let's see. Yeah, let me try to figure out how to unmute somebody. Micah, you wanted to say something? Are you still here? Let me know. Let's see. How do I unmute you? Yeah, you're still here. I'm just trying to unmute you somehow. Let's see how do I do this though.
Yo, you hear me?
Oh yeah, we can hear you now. Cool.
Okay, so makefile. I mean, honestly, they get pretty complex. I don't remember the exact formatting off the top of my head. It's been a while since I've used one, but the useful thing about them, this is something you'll see with, I think project 2 and maybe 3. I don't remember off the top of my head. I'm pretty sure project 2. You can use source code. So you can have a file that's your source code, and you can have the make file just run that instead. So you don't necessarily have to type everything out in the make file. It can just have a source code being run from the make file that's included in the folder. So that's one reason make files are useful. You don't want, obviously every computer has its own command interface. You don't really want the person to have to install an IDE necessarily to run something. So makefile lets them just run it through that, just reading the whatever source code you put in. So that's cool. Also, to mention that one question earlier about using this versus saying like person with the double colon. As far as via Visual Studios goes, they're interchangeable. I don't know about C-line, but one's saying like they belong to person, and the other is saying this variable, and so that means like that basically means the exact same thing. They're interchangeable on Visual Studio. Just to answer that question earlier.
He can't hear you, by the way. Probably because I was talking. If you want, you can ask him. I mean, I'm just saying, like, I'm pretty sure it's using the mic. Yeah, that is indeed Fernando, my boy.
Okay, so what was the question? Because someone, I realized there's another chat and someone yelled in my ear right as that was being said.
She doesn't want to ask.
Okay. Also, can I mention something? This is kind of related.
Yeah.
Guys, you're not going to get points off for this. This isn't something that we're going to grade you on, but please don't use structs or public variables for stuff that should not be changed. I've seen a lot of people use structs and public variables for their recent labs where it's data that's coming from a file. Now this is fine. You're not going to be graded on that. You're the only user, so it doesn't really matter. In real life, you definitely don't want to do this because that means that this data is now able to be manipulated by the outside user. And that's why we use getters, is so that we can get data without it being manipulatable by the user. Just wanted to mention that to you guys because a lot of people seem to not quite understand the purpose of a getter versus just making things public. A public variable is manipulatable on the outside in the main.cpp. And so the getter is to get around that problem.
Do you guys hear everything you said? Okay.
Just some good coding kind of rules there. Again, not something you're going to get points off for. Just wanted to mention that deal.
Okay, cool. If you want to ask a question, you have to speak into the mic. That's like the rule. Yeah. Yeah, the previous one. Hold up. Let me actually. There you go. Yeah. Do you want to ask Hernando or like?
Okay, so like I made my weapons class a struct. Is that bad? It's like, it's under public and then I made it a struct too. Double coverage. Hello? I don't think, wait, can you hear me? Can you hear me anymore?
You should be able to hear.
He's silent. Maybe I'm.
Yo, Hernando, did you hear that or no? Guys, he's gotten mute. I don't know. I'm not going to question. But anyways. Yeah, what's up? Let's go. Can we get a round of applause? Let's go. For you guys on the Zoom who are not like on the who are on the Zoom who didn't hear that, there's no binary file IO. Yes, Bagman.
I've been wondering, like the very start when you first like started showing writing that you did, you know what I mean?
Yeah.
Who's Joe?
Who's Joe? Oh, no, it's over. No. It's over. Oh, wait. Was Hernando muted again? Oh, my gosh. How do I? There we go.
Chris, you can just make me a co-host.
That's a good point. I don't know how Zoom works.
I didn't realize it would revoke my permissions if I muted myself again. But so that question earlier, is it a bad thing to make your weapons a struct? Honestly, yes, in real life. Think about this. So what was the point at lab? You're reading from a file and getting all this data for the starships, right? Ideally, should you be able to change the data of the weapons inside of a starship as an outside user? Right, no, because this is just a printing and this is just a printing lab. Like it's just an algorithm to find like max stuff. So in the real world, obviously, you know, this is kind of a bad example because if you had some kind of game with ships and stuff, you would want the user to be able to change stuff. But if it was any other kind of data that's not supposed to be changeable, now anyone can change it. You also run into the potential when you're coding yourself to accidentally change values. Whereas if it was private, it would tell you, it'd be like, you can't change this. Well, when it's public, there's not a chance of that happening. It's just going to straight up let you change the value. And you won't know that something changed the wrong value until you finally find the error, probably using print testing or something.
All right, so there's that answer. Brian, did you have a question for me or for Hernando? Here. Brian had a question, so I'm going to hand him the mic.
Hello.
Hey.
Earlier you mentioned that that you make fields private because you don't want outside users accessing those values. Is that correct?
It's not so much access. It's more about changing the values.
What do you mean by outside users?
Like, say you let's say you move these files over to I don't know. But you made these files uneditable, right? like at least the header file or something. These are on a server or something, right? Well, you wouldn't give any user access to like the actual source code in the server. But it's kind of weird. It's hard to give an analogy with something like this. But what I'm basically saying is private variables should remain private. They should only be changed in the context of the class. You wouldn't want like, because what happens is if they're not private, any program, which includes this header file, can now change the values inside of the class. So if you just call it include with this header file, you can change any of the values that you want. Which means if you're reading data from a file, you can change the value of the data read from the file, which probably isn't what you want to do. You probably want to have that not be changeable. It's hard to kind of, I'm trying to say it the right way. Let me think about how to say this the right way.
Well, while
Okay.
you're okay.
You know how private variables aren't changeable outside of the class, right?
Yes.
Okay. So if they're public, you can change them in any file that includes the class file, the header file, right?
Yes.
But if you're reading data from a file, you don't really want that to be changeable on the outside, right? Like you don't want any file to just come in, include the header, and now I can change the data that's being read. In real life, that's more applicable to like security, I would guess, because there's certain data that maybe you'd be okay with users getting but not changing. Say like, there's a kind of a bad example, but say like your bank account balance, you can read it at any point, but you can't go in and just start typing numbers and changing the bank account balance yourself, right?
I've heard the bank account balance analogy being used several times, and yet one of the recent lectures from Professor Fox has stated that the purpose of the private access modifier is not actually about cybersecurity. It's more about preventing other programmers from changing values that you don't want to be changed.
Right. Which, again, that's not so much security as you said, but it's still kind of the same concept of you don't want outside programmers to just come in and change this data. Right?
Well, then how about this? Okay, say you make a variable private, then you make a getter and setter for that variable that's public. Wouldn't an outside user be able to access those getters and setters?
Right. So usually you wouldn't. It's a little weird. Like for this recent lab you did, you wouldn't make a setter, right?
Okay.
You would only have a getter on the outside.
Wait, hold up. I was just gonna make an announcement because like I don't want the recording to last too long for like the Zoom. So I'm gonna like end the recording, guys, just so you guys know. Yeah. Obviously we can stay here and continue with questions.
Yeah, Brian, that's more like conceptual, like what would be the right thing to use here? Should I have a setter? Should I have a getter? But as long as you understand why